So this week is all about functions, but before we dive into functions, we're going to talk first about relations, which are a little broader than functions. So a relationship a relation in math is just a relationship. It allows us to take something from one set and talk about how it maps or is related to another set. Typically, we call this first set our x and second set our y, and even more specifically, all of the values that make up this set of x's is what we call our domain, our inputs, and everything here in our y's is what we call our range. So we have our input and we have our output. And one thing to keep all of this straight in terms of mathematics is all of this is alphabetical. Oh no, that's not what I wanted to do. I don't know where my undo button is. It's missing. Oh no, this is tragic. I can't undo this. I'm gonna have to, dang it. Guys, you don't understand how much this upsets me. I was trying to use the highlighter. So X, D and R, I and O, it's all alphabetical. So it's kind of easy to keep the domain and range straight. Also your input output. So there you go. Now, ways that we can represent these relationships in mathematics. The first is what we have here, what we saw today in class, a table. So we could take something like the number of people in a group and map this to the number of handshakes necessary for those group members to meet. So that's one option. There's another thing we can also see called a map. It's sort of the same as this, but I'll just be lazy and remove this, where we just take and do arrows to sort of show what goes together. So that's a map version of this. So that's another alternative. We don't see that as often in algebra. We could also use a solution set or a set. When we talk about sets, we use curly Q brackets. Now, it wouldn't be very useful to have the X set 2, 3, 4, 5, and the Y set, right, our range, separate, because there's no way to know usually with this curly Q, these braces as we call it, this is called a brace. There's no way to know an order. It's not an ordered thing. The set is just all the possibilities. So this doesn't make it obvious that the 2 maps to the 1. So if we want to use that set notation, what we actually have to do is we have to use ordered pairs. So 2, 1. So now we can see our X and our Y together, and then 3, 3. So that's another way to represent this. And then for those of us who remember some algebra from way back in the day, perhaps, we would recognize these things as ordered pairs, right? Or coordinates, which we saw today in that personality coordinate thing. So yet another representation would be to use a graph, right? So we could sit there and graph this thing. 2 people takes 1 handshake. 3 people takes 3 handshakes. 4 people takes 6 handshakes. 5 people takes 10 handshakes. And we're starting to see that kind of quadratic thing we were talking about, right? For those of us who remember parabolas, we only got half of it. And this is a graph where it wouldn't make sense for us to connect all of this with a line because there is no way to have 1.5 or 2.5 people in a group. So we would actually just want to leave this as those points floating about. There's one more way we could represent this, and that's algebraically. Oh my God, algebraically. I could not do that without thinking for a second. And that's with a formula. And this is where our function notation comes in. So this is our first look at function notation. We saw this today, this idea that n times n minus 1 divided by 2 was a good way to talk about h, right? We could say h equals that, or we could use function notation, which we're going to learn about tomorrow, and say h of n. So the number of handshakes given n people in the group is n times n minus 1 over 2. So again, for now, you can just sort of ignore that parentheses and just think of this as h equals n times n minus 1 over 2. So those are all the different ways we can represent relationships in mathematics. The last thing, and the thing I'm going to have on that quiz for you guys tomorrow, is the difference between a relation and a function. All right, so relation is any set mapping to another set, any rule that gives us one set to another, right? A relationship in mathematics. So here's an example of a relation, right? We could have our x's and our y's, and we'll just do a map for this one. 1, 2, 3. 1 maps to 1, 2 maps to 1, 2 also maps to 3, and 3 maps to 2. This is a relationship. Doesn't have to make sense, doesn't have to be any reason for it. We could rewrite it in all those different ways we talked about, right? We could rewrite this as a bunch of ordered pairs. We could graph this thing. Oh gosh, it takes me a little longer sometimes. So we got all of our different points on there. This is fine. This is a relationship. This, however, is not a function. So when you want to think about a function in particular, you want to think of sort of a machine, right? So we have some sort of machine. Think of this as our function box. And we're going to put in an x. And the x is going to travel through. Stuff is going to happen to the x, and then it's going to pop out. And it will be a y. Here's the biggest thing. If I throw an x into the machine, I can only get one y out. That is the biggest piece that we need to know. Every input, every x, every element of our domain has only one output. So this previous one was a problem. Here, the number 2 had 2 different outputs. The machine was essentially broken. If I put in 2, a function will always give out the same value. It won't give out 2 values or a different value each time. It will always be the same. So we can see that here. Again, the 2 has maps to 1 and to a 3. And here in our graph, the x of 2 has 2 different points there. These are all problems. So our previous one was, we do get some students who get confused. It is okay for multiple inputs to map to the same output. So it will be okay for 1, 2, 3. It will be fine if every single one of these things map to 2. That is completely okay. In fact, I can even write this as a function. This means whatever input I put in, it just pops out a 2. Graphically, no matter what the heck I put in, I get 2 all the way out. It's a very consistent machine. It takes any number you have and it turns it into a 2. So that's the difference between a function and a relation. It's pretty easy to see when you have the map. You don't want to have this happening. If you have points, you want to just look and see if you have any input twice. It would be a-okay if I was repetitive and had 1, 2 in here twice, because that's just the same point twice. It's not the same number mapping to something new. And then on a graph, what you don't want to see is your graph failing what we call the vertical line test. So right here, if you ever can cross a vertical line over your graph and it touches more than 1 point, that means there are 2 outputs for that input. So you don't want to have any issues like that. Here, any vertical line I test is fine. It only hits the graph once. So I'll give you one more example of that, and then I'll end this video so we don't have to make anything too long. So let's test out that vertical line test. Okay, so I'm just going to draw you 3 graphs, and I'm going to have you guys decide whether these graphs are or are not functions. We got that one. Let's do something like this. And then that. All right, so take a moment, just decide function, relation for each and every one of these. So again, it's all about the vertical line test. So if you need more time, pause the video and start over. Start after you made your decisions. But you can just sit there and sort of think about chopping any of these graphs with a vertical line. It is okay as long as we only hit the graph 1 time. Perfect. Perfect. What isn't okay is this. So these 2 are both functions. The last one, on the other hand, is merely a relation. It still is something mathematical. It just doesn't fit the rule of what a function is. So that's it. That's all you need to know for tomorrow's class. As long as you can check the vertical line test, you should be good to go on the quiz.